Alô, alô, testando, testando. E aí, pessoal, beleza? Oh, hello everybody. Welcome to another class. Let me see if everything is working fine. Hello everybody. Welcome. And again, I was start the class in Portuguese. So, let's go. Today we will keep learning. We are still in the module called intro. So we are learning the basic. Last class, we solved the problems for the input output, and we're gonna keep learning the basic things. So today we learn about assignment and expression and the math operations. Okay, I already kept this on the side because I would like to clarify something, so I will keep this. I already prepared to give some nice explanation. So let's go. Let me make something like this. Okay, and here I guess I can zoom a little bit. View, zoom. Where is the zoom? Zoom here. 150 is too much. No, let's keep up zoom. I'm supposed to have a zoom around here. View, zoom 100. Let's keep this way. So I put a URL here just in case you need to see more details. You can just open this guy. You come here, is a W3 school, so there is very good training here, so you can learn almost everything I'm teaching here just by going through this, and there is details there. So I explain what is here. Some of those operators we'll learn later on, but let's go. So first thing, the equal sign means assignment. We already use that a lot. I even put like a smile here because of this. So this is how we initialize a variable, and you assign a value or expression that will be translated to a value to a variable. In this case, I have a variable called name that you receive the string José Santos. So maybe you can do like a certification test, and one of the questions is, what is the type of the variable name after the execution of line 6? We can see that is a string because Python is a dynamically typed language. Whatever is being assigned to the variable will be the type of that variable. Some languages, when we declare a variable, we have to tell the type, and and that means this variable can only receive strings. Even later on, we can only assign a string. Python does not have this limitation. So it's a dynamic typed language, as opposite for the static language, static typed language. We can do multiple assignments in just one line. For example, we can say number 1, number 2, number 3, name. We receive those values. So 5 goes to number 1, 10 goes to number 2, 15 go to number 3, and José Santos go to name. So they are positional. Whatever order we have values after the assignment operator, that is equal, will put correctly. However, this is not recommended. I like to show because you may be reading someone else's program and you can see, okay, what is going on here? So basically is, I want to assign values to all those variables, all those 4 variables. And those values are here separated by comma. Okay? This is what is recommended. So back in the days, we like to have a program that was as smaller as possible because we thought, oh, we are saving memory and that. But today, we value more like what is a clear code. Even if there is some extra line, it's better because now I can see easily that number 1 receives 5, number 2 receives 10, number 3 receives 15, name receives José Santos. In this case, I have to kind of do some analysis to see what is going each variable. In here, there is no doubt. It's easier to read. So it's like a text. This you are kind of make harder for people to read, and here is easier. Okay, And there is no advantage to this, say, oh, I'm using just one line in opposite of 4 lines. But if it's easier to read 4 lines, go to the 4 lines. Okay? We can do multiple assigns for the same value. So if we have A, B, C, D, and E, and we want to assign to all those variables the same value, we could say something like this. So that means all variables will receive the same value. So let me do this. I will put a breakpoint here. And we can debug, so we can see already the result. So we don't need to do it again. So what I'm doing here, create a variable that will receive the string José Santos. And the name is name. So this is the variable. See, this we are looking at a representation of the computer memory. The next line will declare like 4 variables. Each one will assign new values. So name is not going to change because I'm assigned the same. So I could put a different name here. Now I print all those values we're going to see here. And now we are doing the same with new values. So let me do this to be a better example. So here I will change the name to Leila. And let's change the values here to 50, 100, 150. And here we change to R2. Would be a better example, no? So now we can see, for example, in this line, name will receive José. In this line, those variables will receive those in sequence. See, name now change to Leila. And now we're gonna change number 1, number 2, number 3, and name will be Arthur. And we will print all those values. Cool. Oh, and now what you're gonna do, get all those variables A, B, C, D, E, and assign 15. This is okay because we can easily see all those variables will receive 15. So I will not say it's better to have A equals to 15, B equals to 15, C, because in that case it's different, because I can just need to look to one place to see the value that all those variables receive. So in this case it's fine. I would not put like 5 lines, each one receive 15. It's different from this case because here we have different values and I have to see 5 goes here, 10 go here, 15 goes here, and Leila's go here. Okay? Now it's very common, and sometimes people get confused that we use an assignment with expression. So this expression is number 1 plus 3. So let me show how this would work here. So we have the variable number 1 that has, what is the value of variable number 1 right now? Is oh, sorry, is down here. Number 1 is 50. Let's say that this variable is called number 1, and the type of this variable is a string. So it's here. Number 1 in lowercase. Now we are saying another variable. Let me copy those two. Oh, come on, not this. I want to copy this. There is another variable here that there is no value yet, that is called number. We don't know the type yet. So this is this part. Number is a variable that we don't know the type yet. And number will receive whatever is stored in number 1 plus 3. I'm showing this because once a student said, oh, teacher, I was understanding everything until we start to do math with letters. I don't know, like number 1 plus 3, what that means. Well, it's very important for us to understand that number 1 is a variable, and in here we use the value, so it's 50. See, number 1 is 50. So that means the computer will get 50 plus 3, and the result will store in this variable. So now number will receive 53. Okay? And we print it there. Number 1 is 50. Ah, come on, Jose. I should have print number as well. So we'll see both. Let me put a breakpoint here. Here. Remove this, and then run again. Don't be lazy, because we need to run a program multiple times until we have it good. It's the same as a text. If you are writing an essay, or if you are writing a letter, anything, you can't expect to just write once and already be good. Even okay, you have to read again, fix it. The same for a program. So we cannot be lazy to run and test our program multiple times. So we are in this point where number will receive number 1 plus 3. Number 1 was 50 plus 3, 53. We will print number 1, and I'm done. See, this was supposed to be number 1. And now you print number is 53. Another example is we are getting number 2. We receive number 3. That number 3 is 150 plus 10. So how much will be? 160. And now you print number 2. And here should be number 2 as well. Actually, I would like to show something different here. I would like to show number 2 plus 10. That was the example I like to show. Let me put another breakpoint here. Sorry for this, but we are learning more. So see, it's very common to use a variable to increment it. So in this case, is an assignment that I'm creating a new variable, receiving number 1 plus number 3. So this expression that will be executed. So if we add this to, where is it? Add watch. See, number 1 plus 3 is 53. And that result is stored there. Now it's different because I'm using the same variable. It's the same idea. What is the value of number 2 here? 100. So if I get this expression and I ask my IDE to, okay, let's see what is that. So number 2 is 100 plus 10 is 110. Look, this looks strange, but the same variable is being used to be updated. So you read the same way. Whatever value is in number 2 here will be used plus 10, and now number 2 that was 100 will receive 110. Cool, and now I'm gonna print it. So assignment is so common that there is some augmented assignment. Just to avoid things like this, number 2 equals number 2 plus 10 or plus something, there are some assigned that we just say this: plus equal, minus equal, multiply equal, or divide equal. And what that means, A plus equal B is the same as A will receive A plus B. So this plus equals is like we are using the same variable on the right side. So let me fix something else here as well. I will put a breakpoint here. I changed something, but I didn't change the variable's name. So I put number here. Let me copy this. I was doing some improvement in the material, so I forgot to change the variable's name. So let's debug this and see what is going on. I'm just printing number 1. So you can see number 1 is 50. Now I'm doing number 1 plus equal 1. This is the same as number 1 will receive number 1 plus 1. So number 1s go to 51. See? Number 1 after plus 1. I can do the same with subtraction. This is the same as number 1 will receive number 1 minus 3. So how much will be it? 48. I print 48. I can do multiplication as well. So this will be the same as number 1 equals to number 1 multiplied by 2. So number 1 now is 48, goes to 96. And we're going to print it. And we can do division as well. So number 1 will be number 1 divided by 2. So we go back to 48. Pay attention to something here that we'll show later on. Number 1 now is a float. That's because the division operation always convert the result to a float. It's very important to pay attention for this. We'll see some example of this later on. And let's go here. And then we can, let me fix something else here. I feel so bad for this guy. This is at minus number 1. So let me remove this breakpoint and let's go. So what happened here? I say that number 1 will receive minus number 1. So this is pure math. Whatever signal we have in number 1, if it's positive, will become negative. If it's negative, it will become positive. So this is base math. I can say, okay, number 1 is 48. So now it will be minus 48. I am inverting the signal. And now when I print, I will see that is minus 48. Just to make it like a better example, let me repeat this and you can see what will change. I'll save, run again. So look, number 1 now is 48. Minus 48 is minus 48. Now number is minus 48. Minus 48 minus 48 become plus 48. Remember, minus with minus is plus, right? Let's see why didn't change. Minus. Oh, because I will do now. I'm done. Now is 48 minus 48 will become positive 48. Did you get that? So here the number 1 was positive. We make it negative. And then we did minus, negative, become positive. So the math works. The computer knows how to do math. So every time you put minus a number, we're going to invert the signal. If it's positive, it will become negative. If it's a red negative, it will become positive. Okay? Now let's say number 1 plus equal number 2. So who is number 1 now? Number 1 is 48. Who is number 2? Is 110. So number 1 will receive 48 plus 110. It will be 158. Oh, let me remove this expression here because it's... And now you print it. And one thing, there is no plus plus or minus minus in Python. So whoever is coming from C, Java, C Sharp, or Scala, or Kotlin will miss that. So instead of plus plus is the variable plus equal 1. Okay? Now something very important that probably you will miss in some point, because it's very easy to forget this, that the computer follows the math rules. So that rules is division and multiplication has a higher priority than addition and subtraction. So if I want to find an average, I have to first sum the 3 numbers. Is that why it's between parentheses? Is how we increase the priority. So whatever is inside parentheses will be executed first. After we execute this, then we divide by 3. See, the average is 139. If for in case we forgot to do this, look at the difference. Because now we are only dividing number 3 by 3. That will be 50. And we are adding those other 2. So look how different the response will be. 318. This was already a source for bugs in coding. So now you see why it's important to pay attention to details and to test the result, because if we don't test, bugs like this can just go, and we can imagine that we are calculate the score of a student. If you calculate this way, see, it will be 139. If you calculate this way, probably every student will pass, because we're gonna just sum these two, and then we'll divide only the last like number by 3. Okay, one thing, this is very simple, but remember, everything I'm teaching here we'll need later on when we are doing coding. Coding, we don't have too many tools, but we need to know those tools very well. So review this, make sure that everything is clear, put breakpoints, go line by line, and try to digest what I said. If you don't do this, it will be very hard for you to keep the pace as we are learning. Okay? This, I bet you do this mistake once in a while. I already did, and sometimes I do. We just write the expression, we divide that, but we forget, oh, I have to increase the priority of those operations. So see, I put here the wrong thing. All we learn here, we'll need later on. So that is why coding, I like to compare code like someone, why code is hard? Because we'll solve a problem that we know how to solve. Because if you don't know how to solve the problem, you cannot code for it. Because what we need to do is we have to solve that problem in a way that the machine can follow the steps. And it's like, imagine that you have a car shop, you fix car, and then you have in your office all the tools that you need. So many different tools that help you to disassemble an engine, to change the brakes, something like that. But imagine that now, instead of having all those tools, you just have a small subset. You only have a few tools to do the same job. The job is the same. But now you have to do some extra steps, break down in smaller parts to be able to do the same job. That is why coding is hard, because we need to prepare a sequence of steps that a machine can follow. And we have to use a programming language. There is no other, at least so far, there is no other way to really tell the computer how to execute an algorithm. Even with AI, all that can improve a little bit, but it's far from we don't need to do coding. One day, maybe 100 years from now, 1,000 years from now, probably everything will be different. But believe me, we'll be retired. Even if we start today, you'll be retired until we don't need to code anymore. Any other profession, thousands of years from now, will be gone. It will be all automatic, but not for now. Even if the AI that you have now, we are not close to that. Cool? So just to going back to the example, I like to say that to be able to code, we need to write steps in a way that something very dumb, like a computer, can follow. The computer is the dumbest thing that exists. Cannot have any doubt. Has to be exactly the way that we tell to do. There is no interpretation. So that is the challenge of code. We need to get a solution that we could explain to another human and break down in small steps, simple steps that a computer can follow. So we have that ability to how we can be smart to translate a solution to be expressed in a way that a dumb thing can follow. I would say that the challenge of code is that we have to become dumb to be able to break down the solution in those single steps. Because what I'm showing here is what we have in code. Okay? So this was the file for assignment. And now let's go to math operation. A lot of people say that coding is all math, but it's not true. Of course, there is a lot of things that we need math. For example, you go to a grocery, you buy a bunch of products, you need to pay for it. So you have to calculate the total. And it's not just the total. We need to calculate the tax. That is the math we use in computer most of the time. Is the basic for operation and percentage. How to calculate a tax, because the word is based on that. So you don't need to at all be good in math. You just need to know the 4 basic operation plus how to calculate percentage. Even if you don't know, there are tools, or you can research how to do. So don't feel intimidated in code, because a lot of example we use math. Even today we see some advanced thing, but that is not the usual. It's just in case if you need, it's there. So you don't need to recreate the wheel. It's already there. You can just use it. Because remember, after all, a computer is a calculator as well. It starts as a calculator and then evolve to what it is today. Is a calculator, is smart enough, but still very dumb, that you can give instruction to solve problems for us. So let's go. I put other 2 links here as well. So is this one and this one. Let me bring this here. The first one is another page from the, oh, what is this? It's from the same WT school that explains those operations. So if you want to see example, read and all that. And the other one is from the Python documentation that explain all those mathematical functions. Here there is way more of what we need, or what you see. So it's just to show you that what I'm bringing here is the core that we need to know to become a programmer. There is way more stuff that we rarely use, so you may go there when you need. But for now, we are focused on, in my experience, what I think is important. Okay, so, input, output, no, and you are here. So this is very, certain point silly. What we do, let's run this. Let me clear this screen here, clear, and then let me run again. And I will put a breakpoint, of course. And by the way, just remember, most of the math operation, we need to import this module called math, because the people that create Python, let me do something else here real quick. The people that create Python create this math module with all the code there, so we can reuse it. So these are the math operation. Let me run so you can see the result. So all the 4 basic operations are addition. So here it says 7 plus 2. We all know that will be 9. Subtraction, 7 minus 2 will be 5. Multiplication, 7 multiplied by 2. Remember, multiplication is this star symbol. And you can see all those, as I'm using integer, the result is still integer. But look now, division. When I do the division, this division operation always return a real number. So 7 divided by 2, and the real word is 3.5. Now I'm doing some expression just to show that you can go as 3 plus 7 divided by 2. So just to show you what happened here, remember, division has a higher priority. Let me close this window real quick. I'm back. So what you do here, we'll divide 7 by 2 first, and then add to 3. So it'll be like 6.5. Now we are doing maybe what to expect. 7 plus 3 is 10, divided by 2, 10. So always remember this from the math class. We need to. And then we can have like some complex operation, like this, 50 minus 5 multiplied by 6. So what happened here? We do first the multiplication, that will be 30. 50 minus 30 is 20. Divided by 4 will be 5. And now we can do something like this. 7 or 3 plus 4 divided by 1 minus 5. And, oh, sorry, I want to click this. That will be minus 175. And we can say, okay, 10 divided by 3. Pay attention to this. Every division, the result is a float. Now we will see two different operators, and it's very important that you understand this. So I open space here for us to review this. Let me do something like this here and create a little bit more space here, because this is important. It's one of the most complex math that you need to learn, is the integer division, because we all knew, and it's how we learn when we are young. And there is a lot of algorithm code that you need to know this. So I put like a warning here to say this slash means integer division. Mod represent the how do you say, the mod of the division. So before we look at this, let me just give an example. If you are doing a float division or a division in the real set of numbers, how we do this? Let me just get this and say, okay, 7 divided by 2 means this is dividend, this is a divisor, this is the quotient, and this is the mod, or the remainder. Okay, so this is mod or remainder. So what happened here? What we want to do is how many 2's we need to make a 7, or from a 7, how many group of 2's we can create. I think it's easy to see this way. How many 2's we need to make a 7. So if I have 1, 2, I have only 2 here. If I have 2 2's, I have 4. If I have 3 2's, I will have 6. And then we say, okay, wait, let me do something like this. I guess there is a way to make this line like thicker. Do I know how to do this? Let me see. There is a place here that I can go. Format, line. I say this. Let's see if this is going to work. So how many 2 I need to go to 7? We all know that is kind of 3. Where we are with 3 2's? In 6. What's 6? Okay. And then we have a reminder. That is 7 minus 6, 1. So in coding, we have two important results for integer division. One is this, that is returned by slash. No, I'm not going to do this. Slash. And the other one is returned by percentage. That percentage is this. If we are doing a real division or a float division, the remainder is always 0, because we put common here and we continue doing it. So just to show you the regular division that we do. So let me do this. How we do this division as float? It's similar, no? We say, okay, how many 2's I need to make a 7? 3. Oops, that 3 is not good. With 3 2's, we are in 6. 6 minus, 7 minus 6 is 1. And then we say, okay, we still have 1. So how did you learn? Well, we put a common here. And this common here means we will add a 10 here, a 0. So now it will be 10 divided by 2, that will be 5. Come on. Five multiplied by 2 is 10. And now the remainder is 0. With remainder 0, we have the result. So this is return, this here. Oh, no, this one. Is returned by the single slash. Because if we're doing a float division, we don't care about the remainder. The only important information is the quotient. Is that clear? Most of the time, we do this division. When I was a professor, I was calling students to the board, to the whiteboard, say, okay, please do me an integer division of these two numbers. The majority of the students could only do this. They could not think in integer division anymore. If I brought little kids from grade 3 or 4, they didn't learn yet this real or float, so they would do the regular integer division. So please make sure that this is clear in your mind, because we will need this while coding. There is many things that if you don't know this, you're not going to be able to understand the algorithm. So I'll explain again. If you are doing an integer division, so when you use like slash, that means there is no decimal. The way that we think is how many, and let me give the names here. Maybe not to confuse you, but those names are, I hope I remember correct. This one here is dividend. So set is the dividend. This one here is the divisor. This one here is the quotient. How is quotient? Quotient, sorry. And this here is the remainder. Not sure if it's remainder like this or like this. Remainder. Well, you can figure out. When we are doing a float division, the remainder is always 0, so you don't care about it. If you are doing an integer division, not always the remainder will be 0. Because how the integer division works, how many 2's I need to make a 7? If I use 4 2's, I go beyond, because it's 8. If I use only 2 2's, it will be 4, and I could use another 2. So the right number here, the quotient, is 3. With 3 2's, we can make a 6. And there is a remainder of 1. So in the integer division, there are two important results. The slash give us the quotient, and the percentage symbol give us the remainder. Okay? This is so important that I would like to show in another way to make sure that you all understand, because we will use this in multiple algorithms in the future, and I want you to make this clear. It's the most complicated math you need to know to learn how to code. And it's funny because this math you learn in grade 3, 4, or 5, something like this. Okay? So if you are doing an integer division, it's like this. Imagine that you have like 7 oranges. And then we want to divide in groups of 2 oranges. So what we do, we get something like this. It's a different way to see division, okay? You get those 2 oranges. And I say, okay, we need one group of 2 oranges. So I can come here and say, okay, one group we will need another group of 2 oranges. I'll come here and say, okay, we need another group. We will need another group of 2 oranges. And now we cannot put another group of 2 oranges, otherwise we pass. So what we do have here, we have this. And we have a reminder of 1 orange. So I forgot to put the last one here, no? 3. So the quotient is 3 because I need 3 groups of 2 orange to have this. And having those 3 groups, 1 orange will be reminder. Okay? Will be the mod. So now I hope it's clear in your mind. We're not going to use this right now, but at least when I mention, that should come to your mind. So look at this. We are doing the integer division. And now 7 slash 2 means this, the quotient. So be 3. 7 percentage 2 means this here. So it will be, after we do the integer division, how many left? For example, if I have 9 oranges and 2 people, how I divide those oranges to 2 people? I give 3 oranges for, I gave like 3 oranges to each one, and then 1 will be out. I can split that in the middle, but as we are not doing float division, we cannot split anything. I say, okay, each one get like 3 oranges, and I have 1 to myself, or I give to someone else. Okay? So this to show you something like this. Div mod is a function that already get the quotient and the reminder. So instead of do this and this, in just one single operation, we do something like this. Give me the result that will already be the quotient and the reminder. So if I print this guy, the result, you see that is like something like this. The result will be 3 and 1. So this guy here will be result 0. That is the first position in that result. And this one here will be result 1. So it's like if we do instead of slash or this, we receive like 2 boxes. Where the first box has an index like 0, and the second box has an index that is 1. So is that why if I do div mod 7 by 2, the first one will be the quotient, the second one will be the reminder. If we don't get this now, don't worry. But make sure that you understand what is an integer division. It's just a division that is not in the float realm. So we cannot split something in the middle. okay? If we need for n case the value of p, we can use math.p, pi, p is in Portuguese, pi. If we need to do a power, so 2 power 0, we just do this way. Any number power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, is this number multiplied by itself this many times. 2 power 3 is 2 multiplied by 2 multiplied by 2. So that is 2 multiplied by 2 is 4, multiplied by 2 is 8. And then 4 times will be 16. When do I use this? Well, wherever you are doing a problem that you need to do a power. Sometime you are solving an equation or doing some math, and then it's going to tell you, oh, how you calculate something. Okay. And now there is something cool as well. Imagine that we have 3 variables, number 1, number 2, number 3, and it's very common. What is the maximum or the minimum value? So there is a function called mean, that we pass how many variables we want, and that function will return the smallest one. So the minimum between n1 and n2 is the value of n1, because it's 5, is the minimum of 2. The minimum between n1 among n1, n2, n3 is still 5. The max m1, number 1 and number 2 is 10. And the max of all 3 is 15. So this is something that was created by the Python team, and we can just use every time. And in the filter we use this, it would be very common for us to get some numbers, or give me the maximum, give me the minimum. So remember, we are learning a small set of tools that we can use to solve all the problems later on. It's like you have your car shop, and now you are traveling with just a box of tools. Probably you have a hard time doing trivial things that will be trivial in your office, in your shop, because you already have everything in there. And here there is something as well. It's not important now, but it's good to know, called scaling. That means give an integer. What is the next highest integer? So 10.1, the scaling will be 11. Oh, teacher, oh, Zé, when I use this? When you're doing an algorithm that you need that you need to get the next integer. It's not very common, but I'm just showing you because the same 10.7, what is the next integer? The scaling, like looking up, will be the same, 11. The same way that you have scaling, we have floor. What is the previous integer? So previous integer from 10.1 is the 10. Previous integer for 10.7 is 10. Now we have this trunk. That trunk here is fun. We'll have almost the same result, but trunk just say, give me the integer part. You see? Give me the integer part. So it's very similar. We may need one, we may need the other, but look this. Now we have this round. Round is a math concept that sometimes we can tell round up or down. So if we ask to round 10.1, will be 10. If you ask to round 10.5, will be 10. 10.7 will be 11. So round means if this guy passes halfway, we go to the next number. Or we can do like this. See, this is the number 10.756, and we are doing a round with 3 decimals. So look what they're going to happen. We'll get this, and we'll round with 3 decimals. Pay attention that the last 3 decimals is 7, 5, 6. As we are round with 3 decimals, this here is greater than 5. So every time this next number is greater than 5, we'll round this up. So it will be 757. And if you do like a round 0, will be the same as get the next here's 0. So we're gonna get 0, but this is 7. So 7 past dot 5. So we go to the next one, 11. This is another thing that is interesting as well. It's called absolute value, function absolute. So basically is, if the number is negative or is positive, we'll get it positive. If the number is negative, we'll get it positive. So it's basically like the absolute value, we ignore the signal. So if the number is already positive, we just get a number. If the number is negative, we ignore the signal, because it's like this. Minus is just an interpretation. For example, I have 10 oranges. What is minus 10 oranges? Well, only makes sense if someone has orange and I go there and I take 10 oranges. For example, I had 20 oranges. I gave 10. So now I have the 20 minus 10 oranges. The absolute, we just ignore the signal and we get whatever the value is. There is some algorithm that we need to do that. Okay? This is fun, is the logarithm operation. So this is the log 10 x 16 base 2. Do you remember we saw that in, we didn't, so it was another class, never mind. So I'm not going to give a lot of detail, but this is like this. If we do log 16 base 2, it's something like this. How many times will divide 16 by 2 until we get the value 1? Okay, so it will be 4. 16 divided by 2 is 8, so we have 1. 8 divided by 2 is 4, we have 2. 4 divided by 2 is 2. 2 divided by 2 is 1, so we did 4 times. Because this is log base 2. Now we are doing 1024 log 1024 base 2. So that is how many times we divide 1024 by 2 to get the value 1. So it will be 10. If we don't do anything, we say log 10 is log in base 10. So this is how many times we divide 100 by 10 to get 1. So we divide once, we get 10. We divide another one, you get 1. So we get 2 times. And this is the same. Log base 10. How many times we divide 1 million by 10 to make the value 1? So I guess it will be 6 times. Okay? And now is generic thing. If you need to do sine, cosine, or tangent, you just give the number, you get that. Square root is square root of a number. Which number multiplied by itself gives this 1? So what number multiplied by itself is 9? 3. What number multiplied by itself is 49? 7. What number multiplied by itself is 121 as 11, if I'm not mistaken. Yes. And now there is another way to do power. So instead of use this thing here, we can just use a math function. Math power 2 to 4 is 2 power 4. The same, 10 power 3. And now something very cool. I know that the class up to now is a little bit boring, but believe me, we'll need this boring stuff. Later on, I remember, and you may need to come back to remember. Please make sure that you understand this division and understand why the integer division, we have 2 important values, the quotient and the remainder. And why in a float division, there is no remainder. We believe that to be always 0 because we keep dividing. Okay? And another thing very common, in computer, it's very important for games, for statistics, to generate random numbers, because we need to do some simulation. For example, a game. For that, we need to import this model, random. If you want to learn more about it, you can just go here and explain that it's kind of a pseudo random numbers, because there is something that is predictable. It's not a real random, because it's not reward. It's not like to get a dice and throw. But it's very fair. It's very close. Okay? So if you want to learn about that process, take a look here. So how do we use it? We import this function, and then we say random.randint. So this, let me stop the mouse here so you can read the details. Oh, let me stop, because as I'm debugging, it does not show the documentation well. So I put a breakpoint here. I remove this one in the beginning. So look, if I stop the mouse here, read. Return random integer in the range 0 and b, include both points. This is important because some language like C#, Java, this is exclusive. So this will be a random number between 0 and 10, but 10 is not included. In Python, 10 is included. So if I run this program multiple times, every time we will see a different value. So I say random, give me a random number from 0 and 10. Could be 0, could be 10, could be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Any value there, but will be run. The computer will do some crazy math that if you read, you can understand that, to give you a random number. And you can use that for gaming, for like statistics, for something that we need to throw a dice. So it's very cool. And there is a very advanced math behind it. Here I am saying, okay, give me now a number between 5 and 10. Could be 5, could be 10. The same function in C# and Java will be between 5 and 9. 10 is not included. And we can use even negative numbers, -5 and 5. So what I will do here, I will remove the breakpoint, and I run multiple times so we can see. See, we got luck. Number 10 was random, 6, and then 2. If I run again, we'll get, oh, look at this, how all then get 5. This is very rare, no? Because it was 0 to 10. So it was like 1 in 10. 5 to 10, okay, was 1 in 5. And then -5 to 10, that is 1 in 10 again. So this we are very lucky. 5, 5, 5. Let's run again. We get 5, 9, -4. If we run again, we get 7, 5, -4. We got 2 -4 in a row, see? We get 0, 7, 2. So this random int give us the opportunity to like generate numbers so we can create games, luck games or things like that. Cool. Okay, so now let's stop here and let's go back, because what we need to do now is we have this file 06 practice, and then we have 22 questions in there. So we only have class the next Tuesday, so it will be pertinent for you, good for you if you try to solve all those questions. The next question will be, I will be solving those, so you'll be learning it. I want to really make sure that we know in those questions you need to use almost everything that I taught. Everything that is there, you have to use. So it's good because you'll be forced to go back to remember how to apply to find it. So this division here, interdivision will be used a lot, because I want to make sure that you all have that in your brain before we move forward. Cool? So thank you for joining. Have fun, and God bless you. See you. Bye. Ta, ta, ta.